Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Brothers Chaiken, University of Albany, and Joel, South's brother. We're here to hopefully show you how to approach taking SAT math questions, but also approach how to study for the Math SAT. Today and for the next while, we are going to be doing questions from Khan Academy. The SAT, what happened there? Whoa. The SAT, well, you can actually see here what the SAT does. The SAT, or Khan Academy, gives you hundreds of questions to practice from on all the topics that are on the SAT. Today, we are going to do the hardest set of questions in function notation. We strongly encourage you to go get an account on the SAT website, College Board, and start doing all the questions in Khan Academy. So, today we do this is where I got messed up before. Khan Academy gives you 20 questions per topic, and they're set up by difficulty. And today we're doing the last 5 most difficult problems according to Khan. So let's get going. Okay, so please look at it, pause, and then come back, and we'll do it. Okay, so f of x is this type of function, and g of x is another function. Assume x does not equal 0, which the following is equivalent to f of g of x. So this is a classic composition of function problem. You just raise the white flag and say, I will do what I'm told to do. You just do what you're told to do, and you will probably get the right answer without thinking or questioning too much. You just do exactly what you're told to do. But you have to understand that these x's are used in multiple ways. See, this x doesn't really mean an x. This x can really mean anything. So you could say g of little person is equal to 1 of little person. And then f of the same thing. You could make f of a star is equal to a star minus 1 over a star. So these are really more placeholders. Do you call them dummy variables? No. What do you call them?
Yeah. You could call them you could call them dummy variables.
Okay, yeah. So then you just do what you're told. This is f of g of x. Well, g of x is 1 over x. So that means that we plug this in every time we see a star in the f of star. We plug in 1 over x. So isn't that 1 over x? Minus 1 over, then we have another star, 1 over x. Okay, then you have to know something about how to deal with a complex fraction. What's known as a fraction inside a fraction is 1 over 1 times x over 1. So we have 1 over x minus x, and then you look at the answers. And then that actually is one of the answers. I don't know if there's really a faster way to do this. So maybe I
think it makes sense to memorize this business. This business is a proof of a rule that's really helpful to simply know how to use 1 over a over b. When it's defined is equal to b over a.
Really? You're into memorizing that?
Yeah.
I mean, as opposed to my approach would be just know that when you have an a over b over c over d, it's a over b times d over c. And do every problem the same. Really? You're into just memorizing that?
You bet. Yeah.
Really? Wow, I never did that.
Oh, yeah.
I never did that.
Yeah.
Okay. Yeah. Well, that's cool.
And similarly, the similar thing is the negative of a minus b is equal to b minus a.
Okay. Yeah. Saves you a little bit.
Yeah.
But so I don't know if there's any other way. Well, first of all, you have to know what this notation means.
Well, it's helpful. Again, this is helpful in numbers 1 over 4/3 is equal to 3/4.
Yeah.
And also another thing is important to know is that 1 over anything,
right,
like z, is notationally the same as z to the negative one,
Right.
which is the multiplicative inverse of z,
Hmm. But
and
but
that
the other
z multiplicative inverse times z is equal to one.
hmm, yeah.
1 over z times z equals 1.
Right. And then over here you can also do z to the minus 1 times z to the first is equal to z to
Yeah.
the 0,
Yes.
and anything to the 0th power is equal to 1.
Yeah. Yeah.
But that's only
Even
part of this
0.
problem. The other part of this problem is understanding what to do with the function notation.
Yeah.
This is the main part of the problem because the topic is called function notation, not complex fractions.
Yeah. Yeah. The trick, the situation is that the same symbol x is used for three different purposes.
Yeah, see, that's the thing. That's the potentially confusing thing.
Yes, and so when the going gets rough, it is helpful to rewrite. Here's 1, here's 2, and here's 3.
Yep.
You could rewrite 1 as f of a equals a minus the multiplicative inverse of a.
Right. Yeah. Yeah.
G of b equals multiplicative inverse of b.
Right.
And the problem is to write a formula for the function f composed with or applied to the value of function g when g is applied to x.
Right.
And that's equal to, that's some expression that has an x in it. Which one is it? Is the question. So the way Joel solved it was I substitute x, b, I replace b by x in g of b equals 1 over b, and I get g of x equals 1 over x.
Yep.
And then I take a is replaced by 1 over x.
Right.
In f of a equals a minus 1 over a. I do that substitution.
Yep.
And so we get replace the a by 1 over x and get 1 over x minus 1 over 1 over x, and then simplify that to be x minus 1 over x minus x.
Yeah. So that's good. Okay, yeah. So we went through it two ways. Just want to make a quick comment before we end. This whole thing about 1 over 1 over quarter, Seth would simply say that's 4.
4, yeah.
No, I like to do 1 over an eighth. I like to do 1 over an eighth. Why do I say 1 over an... No. This is what I do. I do 2. Oh, Seth's not doing that. Seth's not putting a 2 here. Oh, okay. Well, I do 2 over a quarter. 2 over a quarter represents how many quarters are there in $2? We know how many quarters there are in $2. There are 8 quarters in $2. So that's a sort of a nice way to remember this. This is 2 over 1 times 4 over 1, which is 8. So there are 8 quarters in $2, and that's a way to sort of put some intuition to this type of problem. So, okay, I guess we're done, right?
Right.
Okay, let's
Yeah.
clear all drawings and let's see how Khan Academy suggested doing it. Probably the exact same way we did. There's really
Uh,
only one practical way to do this problem.
yeah.
Let's see. Um,
Yeah.
how come it's not? Oh, there it is. We substitute. That's the critical word, substitution. The answer is very short and compact. We substitute g of x whenever we see x. Okay, yeah. So by
Mm.
substituting, we do this, and we do this, and we do this, and you get the answer. They don't really explain why. They don't really explain why this is true, right? They don't really go into that. And they use the same x, which is potentially confusing, as opposed to Seth, which used the A and the B. But in practice, you are not going to have time on the SAT to write it as an A and a B, but you have to know that.
Mm.
You have to understand that. So I guess that's it, right?
Well, I think the problem, you have to say we're substituting the error here is the issue. You want uh, okay, here. Well, one of the consider the f the definite f of x equals x minus 1 over x, and you have to substitute something involving x, something involving x like 1 over x. You have to substitute it in for the x. So a kind of mistake you could do is forget that substitute x into this expression means that you substitute it wherever and every place that the x appears.
Right.
So a mistake that you must avoid is forgetting about one of the substitutions.
Yeah.
And writing wrongly 1 over x. You substitute 1 over x for the x and forget to substitute.
Yeah, right. Yeah.
There.
Yeah. And then you get 0. Yeah.
No.
The thing to remember.
You have to do both.
The big idea to remember is that this x isn't really, literally an x. This x is what's known as a dummy variable. This x is a placeholder.
It's an x.
This x represents anything. It represents anything literally anything. So it really says f of anything equals the anything minus 1 over the anything.
Yeah. Well, in some programming languages, there is notation that they ought to teach in school.
Okay.
And I think you may not like this, Joel, but I'm going to tell you anyway.
Okay, go ahead.
In school and in math books.
Okay, get to it, Seth. Okay, we got that.
We'll write f of x equals x minus 1 over x.
Okay.
In functional programming.
Yeah, you write x is equal to x equals x minus 1.
No. In functional programming, you will write f without parentheses equals lambda x dot x minus 1 over x.
Okay, well, we're not doing programming.
The lambda tells you
Yeah.
that the x's everywhere in the scope of the lambda, except deeply within it, there's another binder for x that tells you every x in the scope of the lambda functions as the same dummy or substitutor variable. And there's a rule that you could, in a lambda expression, replace the symbol x by any other variable symbol, and it will not change the meaning of this. So in functional programming, they give notation that tells you X is a dummy variable.
Okay.
And then if they want to tell you that X is a certain value to be used in a computation, they will not write it as the binder uh, in a lambda expression.
So
So they make it
so
absolutely clear which symbols are are free variables that stand for values, and which symbols are dummy variables for which evaluation is done by substitution.
okay,
Now,
okay,
now,
Seth, nobody's following
if
you.
you're going to get a job programming the web and using JavaScript, you
Yeah.
better learn this.
Okay, but nobody's there yet.
They use this kind of concept
Fine, but nobody's
in
there
the
yet.
JavaScript programming language, which
Okay.
is one of the most popular programming languages in today's internet web world.
Okay, but most people haven't gotten that.
Most people, there are lots of people who get jobs in the information technology, computing, programming, software development industry.
Yes, I know, but right now,
And all of them, except for the really old ones,
yeah,
who you're hearing about now, whom you're hearing from now, today this concept, this notation, functional notation, functional programming concepts are rampant in today's technology.
okay, but we're working on the approach of helping people get ready for the SAT. So the people who are taking programming now and also preparing for the SAT, this would make sense. But frankly, Seth, let me be honest. I think anyone who didn't take programming has absolutely no idea what you're talking about, which is fine. But
This idea that is popular in the subject of programming, ought to be taught with math when the concept of defining functions with dummy variables that are to be substituted with values, whenever that's taught.
Fine. So what's going to happen if you think that's going to happen is we have to wait till everyone who's being educated now goes right through the education systems, become teachers, then become department heads, who then decide what the curriculum should be. New York State and the governments will decide what the curriculum should be, and maybe 15 years from now, this will enter into the high school curriculums. Maybe that's how it'll work if it's that important. Okay, but that's good. Something to look forward to. And if you do take any programming, Seth's right. This is going to be really important for you. Wow, this is a little bit extra benefit today. We learn a little bit extra stuff, which is, and every time you go on the website, somewhere in the website, the designers who designed all the stuff we do on the computer uses this concept.
I want to give you another beef. I'm going to give you a beef.
Okay, wait. Let's say goodbye to everyone first before you give a beef. I'm sure most people have left by now anyway. But for the few who've left, Seth's going to give another beef. But for now, we'll say goodbye to most people. Have a great day. We'll see you next week. Email us your SAT email questions at satemailquestionoftheday@gmail.com. And if your teacher tells you something in math and doesn't justify it, then text us or email us at satemailquestionoftheday@gmail.com, and we will try to justify whatever the teacher taught you who didn't justify what they are teaching in class. Okay, Seth, go ahead. Do your beef.
Okay. Here is one problem. Solve for x in the equation, in this quadratic equation involving x. 2. Okay, what we say, let's say, let f of x equal x minus 1 over x. Find f of 3. Okay? Two math problems. Both of them have equations,
Okay.
right? These two equations in these two different kinds of problems mean two different ideas.
Right. That's true.
Very different ideas,
That's true.
but unfortunately, exactly the same notation and exactly the same name, equation,
Okay. So how
is
would you
used for
fix it?
both
So
of
then,
them.
how would you fix it? How would you fix it?
Well, I would fix it.
Yeah. How would you fix it?
I would fix 2 by writing 2 as uh let there are 2 ways I would do it. One way is our let. That doesn't work. I would say this. One way is let f of x, and then don't write it as an equation. Write it using notation like this:
Right.
colon equals
Okay.
x minus 1 over x.
Right.
And leave that equation symbol in 2 the same.
Okay.
The functional programming way would be to write in number 2, let f equal lambda x, x minus 1 over x.
Okay.
That's
What
how I
about
fix it.
what about maybe getting away from this and doing let f of star and come up with a is equal to star minus 1 over star, right?
Well, still, it's the thing is, it's this symbol. It's this equal sign symbol.
Oh. Oh, okay.
And indeed, frankly, I would do this. I use different.
Right.
No, thing is, it's a very. The point is, it's a very different concept.
Right, right,
The
right,
two
right, right.
equal signs.
Yeah.
There's no way to use an equal sign in both of them without making the equal sign mean 2 different things in 2 different contexts.
Okay. Okay.
Now, the equal sign here, the equal sign in 1 says that your problem is to find a value which, when substituted for x, gives you a number on the left, and when compared with the given number 0 on the right, those numbers are the same.
Right. Okay. So
and the job is to find a value for x for which this equation is true.
Right. Solve for x.
It means that if you pick the wrong x,
So we know.
It makes sense to pick a wrong value of x, and the equation will be false.
Yeah. Okay.
Number two, this statement can never be wrong.
Okay.
Because it tells you that if you're talking about what f of a number is, that f of a number is what the definition says it is on the right.
Okay.
So this is a definition.
Yeah.
And this is a property or predicate.
Right. Well, this comes back to what we talked about a few weeks ago. This one, the hard one, is the backwards question. Find the x that makes this true. This is the forwards question. Calculate the answer. So this is a calculation, and this is a solving.
Yeah.
And there's so much, and that's right. And we talked about it. Someone should go back. I don't know what date we talked about it, but we talked about the converse of the questions, the backwards questions, and how hard they are. We spent like a half hour on that.
Yeah.
So
Okay. I think we should call it quits for now. I think
yes,
we're boring people.
I think we should.
And we're also distracting them. We're giving them too many contexts.
Yes, I totally agree. I totally agree. Let's get out of here. We're done. Okay,
We're
everyone.
done.
Have a
They're
great
done
day.
for the weekend. The weekend's coming
We're
up.
done.
Oh,
That's right. We're done for the weekend.
done for the weekend.
We take off over the weekend. Okay, everyone. Have a
Okay.
great weekend. If you're watching this on a Friday, and if you're not, well, it's sort of Friday. Okay, everyone. Have a great day. Bye bye.
Bye bye.